Welcome to our second day of the course for Mastercam Basic Post-Processing. Last class we talked about some general concepts. What is a post? What is MPdll? How does Mastercam package up the input data for the post processor? And today we're going to go and look at all of the basics of MP, and when I say MP, I mean the MP language. When we start talking about writing post processors, the post processor is an instruction list. It tells the post engine for a given set of input, in other words, NCI data. This is the type of output that we want. Just responding here to Derek real quick. Yes, I'm recording. Everything's all set up. So in the old days, the first, I should say, not necessarily the old days, but maybe the first 20 years of Mastercam development, when you created your NC code, there was only one file. It was the post file. And somebody was asking me a question the other day about the 3 files that are needed, and I was explaining some other stuff, so I kind of got lost in what they were asking about. But the 3 things that go together for the posting is the post itself, which is the PST, the control definition, and the machine definition. So those 3 components form the entire set of data that is going to create your NC file. The post file itself is written in text, so it's just ASCII text containing MP language instructions that define exactly what NC code will be produced and how that code is formatted. So before a post file can be used, it must be linked to a machine and control definition. And when you select a machine definition in Mastercam, the proper post file and the control definition settings are also brought in when you select that post. As we talked about, although we didn't really get into the demonstration side, the post file itself contains a section of text, usually at the bottom of the post, called, appropriately enough, post text. And what we mean by post text is the strings that will modify the Mastercam interface. Mastercam reads the data when you load the machine definition, and it modifies the interface accordingly. When we say modifies the interface, we're talking about the toolpaths. So some of the strings in the toolpath dialogues get replaced, and it helps communicate intent to the user. So you as the post developer can say, enter 1 to do this, enter 2 to turn on, high-speed mode 2, enter 3 to output dynamic work offset, enter 4 to output special coolant codes, or whatever it is. But the point is that you can create your own instructions that then get displayed inside the Mastercam toolpath dialog. In addition to writing and developing, your post for your own internal use, there's also the ability to write post processors for other people, or hire your services out. And when that happens, a lot of times you want to be able to protect your work. The way that we do that in post processor lingo or terminology is to encrypt the post. The term that they've used for a long time is binning, binning. To bin a post means to encrypt it. And what happens is that you take your post, you run it through a utility with some keywords in the post file, and the utility splits it apart into two files. The post file, which is the settings that are available to the user that they can still modify, and the PSB portion, B standing for binary, which is the encrypted portion of the post. Whenever you have an encrypted portion, you must always have an unencrypted portion as well. So if you've binned a post, you will have two files, and they must have the same exact file name, with the only difference being the extension. So you'll have, name.pst and name.psb. If you move the post file to a new location, you must also make a copy of the PSB, and it must reside always in the same folder. The post executable is something that you should almost never have to touch directly. So MPdll is the post engine. It's got a bunch of libraries and instructions and variables that already exist inside it, and a set of instructions of how to process the data. We don't ever modify the post engine. We only modify the instruction list, which is the PST file that controls the posting behavior. They've got a little note in here. There are some third-party companies and developers out there that use their own DLL, their own post engine. It's getting pretty rare to find them these days. I think Simco out of Denmark does that, but most post developers use MPdll. And certainly that's all we'll be covering in this course. Machine control definitions. Now, this is just kind of an overview as we go through the introduction. I'm going to kind of jump around just a little bit as we go through this information, because some of it we will be coming back to cover in greater detail. And that is certainly true with machine and control definitions. So it won't be today, but I think it's either next class or the class after, we will be going through modifying some machine and control definitions, talking about how they're linked together, and doing some other work with them. But this is, again, just a little intro part. And right now we are going through the introduction to Mastercam Posts, which is essentially the first PDF file in the new documentation. Mastercam Posts, starting with Mastercam X, must be used in conjunction with machine and control definition. The control definition contains many settings that tell Mastercam about your machine tool's control and its requirements. Many post-processor variables are initialized directly from the control definition. Each control definition is linked to one post customization file. However, the reverse is not necessarily true. A single post can be used by several different control definitions, but this is not common. Now, they give you a bunch of information about how you can store settings for multiple posts in one control definition, and do some other things which are all based around sharing settings. So, for example, if you were working for a large company and you were in charge of only developing the posts and maintaining the posts, then it might be a good idea for you, for example, to create one Fanuc 30i control definition and have multiple post processors linked under that. In reality, I have never seen anyone anywhere do that, unless they were good enough that they didn't need help and they were doing it without us knowing. The real, I guess, standard operating procedure is to have one machine, one control, one post for each machine. I always recommend you do that. Even if you have several machines that are very similar, if there are any differences in the posted code, make a set of files for that individual machine. It will just make your life easier in the long run. Okay, so, whatever the machine is, your, Akuma, MB50 or something like that, you just want to make sure that you've got one machine, one control, one post. So when you are working with the machine definitions and you load it into Mastercam, you'll be able to see information about that machine inside machine group properties. So it will tell you the description line, which is set in the machine definition. It'll tell you the actual file from Akuma OSP 5020M 4xmil-mmd. It'll tell you the name of the control definition, and then the post processor that is linked to that control definition. Let's see where we're at. Hold on one sec, guys. Okay. So we've done some practical demonstrations of all these things. Where does the post get its information? It gets it from the NCI file. And this talks about the posting process. You load the machine, you program the part. All of that data gets stored either in the ASCII NCI file or as a set of parameters which are held in memory. We go and we use the post button. MP will process the data, and at the end we end up with the NC file, the NC code. This touches a little more, gets a little more specific on the NCI file, so I think it's important to touch on. The NCI file is organized in two line groups. The first line contains a single value. This is the NCI G code. It tells Mastercam what type of command this is and how to interpret the second line. The NCI reference volume in the documentation portfolio lists all of the possible NCI G codes. The second line contains parameters for the specific type of NCI G code. For example, the NCI G code for a motion command will contain the XYZ position and feed rate plus other data as well. So this example, I'll highlight it, shows an actual NCI line for a linear move at rapid feed rate. And this is the definition. So the first line is the actual value of the NCI G code, and then it's followed by 6 parameters. All of the parameter lines that are output in the NCI are space delimited lines. That means that a space character will always appear to separate whatever values are being passed on the line. In this case, for the rapid move, the first value is the cutter compensation. Second, third, and fourth values, so these values here, are the X, Y, and Z endpoint positions where we're going to end up at this move. Parameter 5, feed rate settings. And the final parameter is the contour flag. MPdll stores these values in the appropriate predefined MP variables, performs additional calculations to generate values for other predefined variables, and performs any routines enabled by your post for the NCI G-code type. For example, breaking an arc at its quadrants. Next, MPdll begins executing MP instructions which are contained in Postblocks. Processing Postblocks. A postblock is a named block of lines of MP statements, called post lines, that can perform calculations, call other postblocks, and sometimes produce NC output. Postblocks are already defined in MP, or you can create your own user-defined postblocks. Most NCI codes are associated with a specific predefined postblock that is automatically called when it is read from the NCI file. This is called an entry postblock. It's an important concept because it is the starting point in which your post, starting point in your post where the instructions are executed. You can customize the entry postblock for each NCI G-code or have it call other user-defined postblocks that you create. MPdll interprets each post line. When its calculations and other processing are complete, a character string may be assembled that becomes a line of NC output. When MPdll determines that an NC output line is complete, it writes the line to the NC output file. When all the statements, according to the logic flow of the post, have been processed, MPdll reads another two-line set from the NCI file. This produces a call to another entry postblock, and the process repeats. The posting process continues in this way until the entire NCI file has been read. When you first start looking at a post, it is important to understand that the postblocks are not necessarily executed in the order that you read them, like other computer programs. The processing order is determined by the sequence in which the data is read from the NCI file and the entry postblocks that are called by those G-codes. MP processing on page 93 describes these processes in much more detail. So we'll come back to that. So we'll get to the processing when we're going through more of the post. Let's see where we're at here. A few more minutes and then we'll break the video. What are the components of the MP language? The MP language has the following features and components: predefined variables and strings. The word predefined in this sense generally means that they are defined inside MPdll. So MPdll creates them, maintains them, and knows about their existence, and generally is going to fill those predefined variables with data from Mastercam, typically from the NCI file, but it could be from other sources as well. User-defined variables and strings. These are variables and strings that you create on your own and fill with data and use as you need them. By the way, I don't know if we talk about, yeah, we'll talk about it in a minute. Okay. Predefined post blocks and user-defined post blocks. Predefined post blocks, and especially the entry post blocks, are really key because no output can occur unless we start with an entry into the post. And the entry is always determined by the NCI G code. So as we process the NCI data, that is going to determine what gets called when. We have conditional branch statements, while, if, and else. We have math operators. We have formulas. We have functions called user prompts, which are displayed in Mastercam when the post is run. The user can enter information to the post with this feature. Post comments. This would be where we have actual comments inside the post itself that are not part of the processing, but are comments to you, the post writer. The string select function, lookup tables, and buffer files. Those are all components of the MP language. Support for subprograms and lathe can cycles, and support for drilling can cycles and drilling long code. Variables. Variables are labels given to specific values or strings that are used by your post. Variables can represent numbers or character strings. There are only two data types in the MP language: numeric variables, which are always numbers, and strings, which is a random collection of ASCII characters. We'll be going through the difference between the two throughout the course. Some variables are used as switches. I'll highlight this because it's important. Some variables are used as switches to enable or disable posting options. In some cases, a variable used on a line by itself can be used as a command word to trigger a specific processing routine. Variables may be predefined or user-defined. Predefined variables are variables that have already been defined inside MPdll. They do not need to be declared in your post except to apply an initial value to them or to format them for output. Predefined variables always end with a $sign character. For example, ABS Inc. ABS-INC $sign. A list of all predefined post variables is located in the variable and post block reference in the MP documentation. User-defined variables must be declared in your post. When we say declared, what we mean is that you must define a variable and assign it a value before you start using it in logic elsewhere in your post. User-defined numeric variables must be initialized and or formatted before they can be used in your post. User-defined string variables must also be declared before they are used. We must create a variable before we use it elsewhere in our logic. String variables always begin with the letter S. Let me blow this up just a bit here. Give it a little emphasis. For example, S colon. Okay, S colon is a string, which means that the value is not necessarily numeric. User-defined numeric variables can start with any letter, including S. Using variables to construct output. MP constructs a line of output by assembling a series of variables found on a post line. To be output, a variable must simply appear on a post line, but it must not be part of a formula or conditional expression. How can we tell if there is a formula or conditional expression present? Besides looking for functions and other things, look for an equal sign. If there's an equal sign, it's part of a formula or a conditional expression. For example, the following line would output the values in strings for the variables $, S coolant, and next tool $. The $E$ creates a carriage return line feed at the end of line. $E$ is the end of line command. N$ is the sequence or line number command. So when you see a line of output in the post that looks kind of in this general form, it is typically going to be an output line. N$, comma, S coolant, comma, next tool, comma. The comma in the MP language separates statements. Each of these variables existing on an output line is considered an output statement. It may or may not output any data. Modality and variable modifiers will affect whether a variable is actually output to the NC file. These are described later in the guide, so we'll get to those as well. String literals. The MP language also supports string literals. These are characters contained within a set of quotes. For example, double quote, M00, double quote. Literal strings are output exactly as you see them in your post. Command variables. A special type of predefined numeric variable in the MP language is the command variable. This type of variable starts a process or action that is part of MPdll. So you can think of it like a trigger that will cause the post engine to do something. They are normally used alone on a post line. MP language command variables include, for example, comment $, which buffers and outputs comments where the post writer would like them, and fleader $, which writes leader and trailer characters for punch tape. Now, admittedly, I doubt anybody in this class is actually still writing punch tape, but sometimes you'll run across an old DNC system that still needs those special characters. And these are typically ASCII characters that are outside of the normal ASCII character set. which we should probably talk about. But we're getting ready to come up on the first split for our video. So I'm going to go ahead and stop the recording, and we'll continue in just a minute with the second part of our hour.